Methanol is a simple alcohol that can be used as a fuel for combustion reactions. Methanol and oxygen react to form carbon dioxide and water. When we use methanol or other fuels to perform useful work, it's the vapor phase that reacts rather than the liquid. The combustion of a vapor is much faster than the combustion of a liquid due to an increased surface area, allowing for more exposure to O2. A common demonstration, known as the methanol Whoosh bottle, shows the combustion of methanol vapor very dramatically. To perform it, I add 40 milliliters of methanol to a plastic jug, then swirl the methanol in the jug to coat the surfaces and allow it to fully vaporize. Then I dump out the remaining liquid and light it with a flame. The flash point of methanol vapor is 11 degrees Celsius, so you'll see that it goes off right away. If I refill this jug with methanol and try and run it again, the reaction won't occur because all of the oxygen in the jug has been used up. Without enough oxygen in the jug, the reaction won't occur. Oxygen becomes a limiting reactant. To look at the relationship between oxygen and methanol as limiting reactants, I prepared a series of methanol rockets with various amounts of added oxygen.
Each of these 2-liter bottles contains 2 milliliters of methanol and a varying amount of oxygen. In this demo, we'll see how the combustion of methanol can be used to propel these rockets, made out of bottles, all the way across our lecture hall.
Here's the first rocket. This contains the vapor from 2 milliliters of methanol and the normal amount of oxygen found in air. This rocket makes it about 2/3 away across the lecture hall. This second rocket has the same amount of methanol vapor as the first, but I've added additional oxygen to it by holding the opening to a stream of oxygen for 1 second. You can hear that this rocket takes off with more force. With more oxygen, more methanol is able to react and it produces more energy. You can also see that this rocket flies farther, hitting the opposite wall of the lecture hall. The third rocket is the same as the second, but now it's had 2 seconds of oxygen added rather than 1. Following the trend, this is the loudest and, note, the brightest of the 3 reactions so far. For this last bottle, I held the opening under a stream of oxygen for 4 seconds, twice as much as in the third rocket. Even though this has twice as much oxygen, the reaction doesn't look any bigger than it did in the third rocket. Zooming out, we see that it travels the same distance as the second and third. Let's recap what we've seen. Methanol and oxygen react through the following combustion reaction. Methanol and oxygen react to form carbon dioxide and water. This reaction produces more moles of gas than it started with, creating an increased pressure that propels the rocket. This reaction also produces heat, which further increases the pressure and the force propelling the rocket. This is generally how we use fuels to do work. The pistons in the engine of a car work in a similar way. In the first rocket, oxygen was the limiting reactant and it didn't travel very far. In the second and third rockets, there was more oxygen added, allowing more of the methanol to fully react and producing more thrust. In the fourth rocket, so much oxygen had been added that methanol became the limiting reactant and it only traveled the same distance as the third rocket.